Alrighty, well, guys, welcome to the end of VMworld. Thank you for showing up. Woohoo! Woohoo! End of VMworld. Closing out the show. So I'm Chris Sears. I'm a systems engineer with Tintry. I've been kind of playing around with Docker for a while. I lead a user group in Atlanta around cloud computing. I did an earlier vBrownbag, and the guys were kind enough to let me do kind of a little follow-up so we could demo a little bit more functionality than I had time to get into on the podcast. So I have one slide, and just a quick reminder, I actually submitted a talk on this and it got shot down, and now I think I know why. VMware had their own Docker plans and they didn't want me being off message, I suspect. So, but just to recap, the story of VMware plus Docker looks kind of like this. So yes, you could run Docker on bare metal, but in the enterprise, it's likely that that won't happen for a long time. So if Docker does make inroads, it's probably going to run on top of some kind of minimal guest OS VM. And then that's going to run on top of ESX. So what I wanted to do is kind of look at kind of what an application would look like running inside Docker, and actually go into some of the cloud stuff that I didn't get a chance to touch on earlier, specifically talking about CoreOS, which is one of the new distros that's trying to be this minimal OS that hosts Docker containers. It'll be interesting to see if VMware comes out with something similar. And then we're also going to look at a couple different ways to deploy it. And specifically, I have an environment set up with CoreOS in Google Compute Cloud and also AWS. So we're going to take a quick look at that and then actually try to fire up a sample application. So without further ado, let's actually see this stuff in action. So let's start out over here on the CoreOS site. So CoreOS, like I said, is one of the new distros that's trying to be a minimal OS and sort of orchestration framework, service discovery framework for running containers. There's a few of them out there, but these guys kind of had a head start on just about everybody else. So because it takes a little while, I want to kick this off. I want to show you what it would look like to launch a CoreOS environment on EC2. So we're going to call this So what I'm doing right now is actually kicking off a CloudFormation template. And this has a number of parameters that get passed in, and then EC2 will provision a number of CoreOS hosts that we can actually use as a cluster to run Docker containers on. And the nice thing is CoreOS kind of has this idea of being very scalable, very stateless. So each host in the cluster can be blown away. You can auto-scale these. You have a lot of flexibility. And they have mechanisms using etcd and some other components, Fleet, for actually making sure that any node can be shot in the head and a new one can be spun up if you need it. All right, so I'm not going to make you guys sit through this. I actually already did one earlier. And if we refresh this guy, it would help if so that's the one we just created. The one I had from previously was here in the Northern California zone. And if we flip over to EC2, you can see that we already have the 3 nodes that I created earlier, the CoreOS nodes. And these are essentially interchangeable. These are just kind of our compute cluster, the equivalent of an ESX cluster just running in Amazon. I'll also kind of give you a quick look at what this would look like in the Google Compute Engine. Very similar sort of concept, but totally different underlying infrastructure. So again, we have three nodes that we could use to run our clustered our containerized applications. And this is kind of the value prop of Docker, is that you're not tied to a specific cloud provider or type of infrastructure. This would run just as well on a private cloud based on VMware technologies or somewhere else in a public cloud. And that's kind of what we're trying to get everybody to see, is that this is a really great abstraction layer. And if you build your applications on top of it, it gives you a lot of flexibility about what you do under the hood. So let's actually dive in and look at a specific application. So I've actually SSH'd into one of the AWS instances or I did a second ago. Try again. And I wanted to show you something from Docker Hub. So Docker Hub is kind of the other part of Docker's story. It's really about collaboration and sharing Docker images that you can run with the Docker engine. So the Docker engine is really the core piece of technology that actually kicks off the containerized processes on an OS. This is kind of like GitHub. And I think this is where Docker, the company, is planning on making all their money. Doing consulting and running this the same way GitHub runs their source code repositories. So I already went ahead and created a new image, and you can see it right there. And what we're going to do is actually jump in and make a couple little edits. And I'll show you what it looks like to push and pull image content the same way you would file content if you're working on a source code repo. So the first thing I'm going to do is actually kick off a Docker command. And you'll notice the prompt change. So I just went from the CoreOS console, and now I'm actually inside the container. And if you look here, it's the container I grabbed is based on Fedora, but it could be based on anything. So you're sharing a kernel, but you can have completely your own user land, and you can make it as minimal as you want. And that's the best practice. Only put things in your container that you absolutely need to run your application. So in this case, I went ahead and started kind of a sample application here. I've been a fan of DevOps Borat for a while, and so I wrote a telnet server that all it does is when you connect, it starts sending you his tweets. So we can take a look at that here. So we'll just make a little change. And this is just sort of arbitrary, but the idea is that when you design things around containers, you're kind of following a microservice architecture. So you want to create small services that do one very well-defined thing, and then the outer orchestration kind of connects them all together in a way where you have a lot of control over scaling individual components. And as long as you can, as long as something can respond to a service, it's a great fit for kind of the Docker model. There's all kinds of different choices about how individual containers find other containers. There's interesting ways of networking them all. We're just going with a simple example here, and it's essentially just a telnet server. So you see, I did make a little change there, and so if we want to actually save that back, we have to actually see what the container ID of this particular host is. So every time you run a process, it starts with that image, and then any changes you make are saved to that container. And some containers you want to just throw away. Other containers you may actually want to commit back to the hub. So in this case, we're going to jump out and commit that change. And so what it's doing right now is it actually just updated the central repo of all registry of all the Docker images, and now I can. I'm sorry, that was a local change. Now I can push it, which actually sends it up to the Docker index. Push. And again, the nice thing about Docker is it keeps all the layers separate. So if you base your image on another layer, and that's publicly available, and that's based on another layer, each of those is managed separately. So it really kind of follows this trend of immutable infrastructure. And if you were working with a development or a QA team, this individual Docker images are a great little artifact that you can share and push around and know it's not going to change. Okay, so let's jump back in. And see if we can kick it off. The Telnet client was actually not installed, so have to throw that on there real quick. And there we go. We have our Borat D server running in a container, running on CoreOS, running in AWS. And that's all I have. Any questions? Probably not. Thanks, everybody. Have a great day.